Hi, thank you. So today, as you guys know, we're going to be demonstrating how Deeplens works and explain our process and creating our first project with the Deeplens and how we can implement this into basically any application that you guys can need. So the Deeplens is just a camera, basically. It's just a small box and it has built-in Wi-Fi and a 4-megapixel camera. The real interesting part about this is in the inside. Inside the Deeplens, it rocks an ATM processor and 8 gigabits of RAM and 4-megapixel camera, and it's also using Intel's model optimization software, where it takes your models and optimizes it to run locally on the device without having to call to the cloud constantly, saving you a lot on costs. The project that I'm going to be walking you guys through today, and the project that we've been working on, is a facial recognition project. Essentially, we use our Deeplens to create a face recognition model where it detects people's faces in the video stream, and we are able to identify people with 93% accuracy. So it's pretty high. All right. So to begin, this is Amazon's machine learning stack, and before Amazon really came out with this technology, there was a lot of different frameworks, such as TensorFlow, MXNet, CNTK, and all these different frameworks had a lot of different applications, and some are better for different things. And if you wanted to switch between them, it was really difficult because you basically had to start over and learn the entire thing from the ground up. But using Amazon's SageMaker, they package all of these different frameworks and up to 10 algorithms into one place, where we can easily just create it at one place, switch between algorithms, switch between frameworks without any trouble. And this Amazon SageMaker can also be implemented into other Amazon applications as an Amazon Recognization, Transcribe, Translate, Poly, Comprehend, and Lex to expand functionality. So to begin, we have to prep all our data to create our model, right? So when we have all the data, just having the data doesn't really mean anything. All this data kind of just is useless if it's not properly prepared and able to make sense of it. So first we need to annotate our data. So we need to give it labels so the computer can know what is what, and these labels need to be concise and consistent. So if we had a list of people who live in different states, and some people wrote New York as their state, or some people wrote NY as their state, we obviously know those are basically the same thing. They are the same state, but the model won't recognize that and will think that it's two different places. So, and that would cause a lot of anomalies and different situations where we would not get the desired results. So in order to avoid that, we want to have it be consistent all the way across the board. Next, we have to pre-process it. After we have annotated our data and made it all nice, so we can organize it, sort it by values, sort it so it's easy to read, easy to use for us, and also for the model to easy to read. Once all of that is done, we have to decide what part of our data we're going to use as our training data, and then what part of the data we're going to use as a validation data. So for the training data, it would be about 75% of your data is going to be for training, and then 25% is going to be for evaluation. So the training data that we use, we put into the model and we train it and we keep running it through till we get a model that we like. But if we use the training data to test our model, it's obviously going to know those things because that's what it's trained with. We need data that is separate and that is unaltered, that we can give it to check to see if it really works, and we can see the efficiency of it and see how it works in different test scenarios and not just the scenarios that we gave with the training model. And that is what we did here. So you take the large annotated data set, we split it into two parts, about 75% for the training, 25% for the validation, and we start training our model. And once we get to a point where we see what we like, we validate it, and then if our validation passes, then we can move on. Otherwise, we can continue training with some more data and keep using our validation data on the side, separate from the training model, to make sure that we're really getting good results and there's no false positives. And then here's just an example of our Jupyter notebook that we use. So using our Jupyter notebooks, we can easily set up just easy to use sections where all you have to do is click and run the code and easily build your notebooks and build your models and just add the data into it, and everything's pretty much done by yourself. And using this, we taught the Deeplens to create a face recognition model. So this model basically, it uses the throughput from the camera and detects faces in real life. It can be moving, they can be still, and it will just draw a box around it and crop that picture out. And this is useful for security reasons. So in our office, we have this set up at our front door, and this checks as people walk into the door. And if somebody is recognized and somebody who works here we know of, and they are able to get in the building and have no problems. But if we have somebody who we do not know or is unrecognized, we can detect that easily. And this is all through Amazon's Recognization Software. So Amazon Recognization Software is used to identify faces and a variety of other things. So as you can see on the right-hand side of the screen, it can shows that who the person is, the face that it looks like, the gender, the motion, so she appears to be smiling and appears to be happy, and we can also detect some other things like as she's wearing sunglasses. And this is all super data that we can use to do something. After that, we used that recognition model to create our recognition software. So this is just kind of a diagram of how it works. So essentially, the model is deployed on the device and we buy it from Amazon SageMaker, and we have a Lambda function that takes the video stream from the device and then crops out pictures of people's faces and uploads it to the cloud. Using this, from the cloud, we take the images and run it through Amazon Recognization, and that recognition returns a unique ID that is unique per face per person. And using this ID, we are easily able to identify people that we know versus people we don't know, and we get a lot of data from it. So again, after each face is detected, we call Amazon Recognization, and this returns a recognition ID. Using this ID, we look it up in a DynamoDB database, and a DynamoDB database is just a database to hold names and values and stuff like that. And here you can see our recognition ID. They're a unique string of letters and numbers, and each of these we have it corresponding to a name. So when we get this ID back, we can associate it with a person. Next, if we are clearly able to match the ID to a face and we are successfully find somebody, then we can send an action off. So here's an example of how this works. So here we can see we have the string, we have the time, date, and place where the person was identified, and if they are in our database, we have the name that shows up, and we can see the percentage of similarity. So we know exactly how accurate this can be, and we can set it to be like a certain threshold. So I have R set above 85%, and anything above 85% I feel comfortable as in that is a successful match, but we can easily turn that up higher. So after that is logged, we can set that up to create a custom action. An action such as logging it into the Slack channel. So this is easy implementation into the Lambda function, where every time the Deeplens recognizes somebody, we have it report into a Slack channel so we know who's coming in and out of our office. We can keep track, and it's really easy to do that. Not only that, though, we can also implement it into an Alexa skill. So we have it set up as Alexa skill, and you can just ask Alexa who just checked in, and Alexa will tell you the last person who came through the door. And that is if we do recognize a person. But what if we don't recognize them? If the match is not found, this can be used to create, we can send an alert out, like an alert text message to a group, we can send an email out, or we can use another Slack channel to just report that this person that came into the door we don't recognize, and it can be a security risk. And then some of the challenges that really make the Deeplens worth it was all this is possible because of Amazon's infrastructure of all this working together. Of course, you can always make this without using the Deeplens. You can make this and just use like a basic camera hooked up to your computer, but it won't flow nicely. So we can get the pictures and then we have to upload it to S3. That part is easily implemented directly into the camera, so we have no extra work, no extra computing time. It all runs locally directly on a device. And then from the device, we're able to upload it and then recognize it and then get the name back and use one of our functions to identify the person. And all of this works seamlessly without having to really do much work. So mostly the biggest challenge is just getting the model to accurately identify faces, which was pretty difficult. And then creating a database for easy searchability and making it work just super fast was also a challenge. And as this is going on, I just wanted to demonstrate how the Jupyter Notebook works and how we really set up our model. So basically, this is what we used. So what a Jupyter Notebook is, it just breaks down code into easy to use small snippets. And these snippets are easily just executed by clicking on them and control entering. And these snippets are just designed to easily create the model and then use it to train and optimize it. As you can see, super easy to deploy, super easy to use. It's really awesome. Thank you.